is division of polynomials. And there's two things. The first one I'm going to show you, let me show you this one. You don't have to write this one down. You don't have to do this because there's no problems. Well, actually, they're going to add, there will be some problems where they're going to ask you to do long division. But the way they've set every problem up that I've looked through so far in all the homework, except for maybe one, you get to do synthetic division. But I'll show you a long division one just to make sure that we understand what's going on with it as we're going through these. Now, here's the thing you got to kind of think about on this one. When we're doing division of polynomials, you have to kind of think back to doing a long division of regular numbers. Let's say you were taking 17 and dividing it into 943 or something like that. Let's make it a little bit longer. There we go. 9,432. Y'all remember how basics on that one? Just kind of go through, because if you haven't done it in a while, sometimes it's easy to forget. Because I remember when I was in college, someone asked me about doing a long division problem, and I think we were doing Calc 2 at the time, and I just kind of froze because nobody asked me to do long division in like 15 years. So I was like, I had to kind of work my way through it. It was like about 30 seconds of just kind of going, I finally remembered, all right, well, 17 won't go into 9, so you basically put an X there, space out. Figure out how many times 17 would go into 94. That's what, 5 times? 5 times 17 would be 85. Subtract those two numbers, bring down to 3. We've got 93. Also going to be 5 times. Subtract those to get 7. How about 8? Get another 82, so that time it's only going to go 4. 4 times 7 is 68, leave you with 14. Okay, and with long division, you had two options of what you could do there. You could either take this number and write it as, if we go old school, let's write remainder 14. Or we could do 554 and then do 14 divided by 17. And they'll still kind of, when we're doing synthetic division and long division on these, they'll still flip-flop back and forth. Sometimes they'll ask you just to write the remainder. Sometimes they may write it in a fraction form. But you're not going to put decimals behind it and go through that part. We're not going to do that one because the way we'll set this up, there's no way to do it this way. So that's kind of what you got to think about as we're going through these. With long division, it's going to be set up the same as doing a problem like this, like long division with numbers. You're going to kind of go through the same process on these. So let's do 3x minus 1. We're going to divide that in 2. 6x to the third plus 7x squared plus 12x minus 5. Okay, and with long division, here's the one key thing when you're doing these. When you're doing long division, you key on the first terms. So the very first problem you're going to do is you're going to start with dividing 3x into 6x to the third. Oh, now one thing I forgot to mention on this one. As you're going back through and doing long division, or if we're going to do synthetic division in a minute, there's two key things that you have to have here. Almost forgot about those. Okay, so two things you have to do, whether you're doing synthetic or division or long division. And this one's already set up, so we're good. We don't have to go through and change anything here. But the very first thing you have to do, you have to have the terms in descending order, just to make it work out. If you don't have it in descending order, just go back and take the terms and rearrange them to get them there. Okay, second thing you have to have. If there are any powers of x that are missing, Now maybe say, how am I going to know if they're missing? All right, let's say that if you have a problem and you start with x to the fourth, then you have x to the third, and let's say they skip over the x squared term and go down to x, and then you've got some number that's there. If there's all the terms have to be whatever you start with your highest power. Once you get them in descending order, whatever the highest power term is, if you start with x to the fourth, you got to have x to the fourth, x to the third, x to the second, x to the first, and then the constant term. You've got to count down every single power. If there's one of those powers of x that's missing in the problem, then basically you're going to, let's see how we got here. If there's any powers of x that are missing, write the missing power, or let's say it this way, include the missing power. And write that with a zero coefficient. So every single problem that you're doing throughout section 4, and we'll come back and do some more synthetic division in sections 5 and 6 and as we go through this one. So this is one of those things that we'll start it in section 4, hit the basics on it, make sure we know what's going on with it, and we'll keep using it throughout the rest of chapter 2 because everything else kind of spins off doing the division that's here. The good news is we're going to do synthetic division, which has a shortcut, and we'll get to that one here in a minute to show you the shortcut for it. So that's what we're going to do. Key thing is you have to have the terms in descending order, and if there's a power of x that's missing, you've got to rewrite that part, include it with a zero coefficient, so that everything works out that way. Okay, so when we're going through these problems, we're going to key on the first term. I'm going to rewrite this problem down here, so we've got more room. It's 3x minus 1. Okay, so there was our problem that we had. And again, we're going to key on the first term. So when we start off with it, we've got 3x, and we're dividing that into 6x to the third. So here's basically your problem. Just divide the first two terms. Take the first term that's here, divide it into the first term here. And the way these should work out, every problem that you have, they should work out to be whole numbers. If you get fractions, it gets a little dicey. So they should be whole numbers as you're working through these. 6 divided by 3 is 2. And with x's, basically you're taking x to the 3, you've got x to the first power here. So you're going to knock one of the powers off, so then that would make that 2x squared. And that's what will be up here. That'll be your first term that'll go up here. So we've got 2x squared. To get the numbers underneath it, you can think about this number being in parentheses, or this expression being in parentheses, so that now you're going to go back and multiply 2x squared times both of the terms. You're basically doing distribute property. So we'll go 2 times 3 to get 6x to the third, 2 times 1 to get minus 2x squared. All right, now let's take a trip back to 3rd grade math. Go back up here. I'll bring it back down in just a second. Where did that come from? You just have to do it, right? I mean, that's part of the problem. That once you do 5 times 17, that's 85. It's not negative, right? You've got to go back and subtract the numbers to get what you need to go from there. Same thing with this one. This is the bring down. That's not a mathematical term. That's just something we do, right? We bring down the next number. So there's a couple of things in there that we do that it's just understood that's what we do. With long division, it's the same thing. You're still doing this one. You've got to subtract both of these terms, which means once you've taken this thing and multiplied it out, you've got to change this sign, and you have to change that sign. So once you do the multiplication on these, you've got to go back and change both the signs, because this term needs to go away. 6 minus 6 is 0. That term is gone, and that's what we want, because it's got to knock it down a power. Same thing when we're doing the long division up here. We've got to get rid of this 9 and get it down so that eventually this thing will be a 0 down there. or whatever it was going to be when we took off the remainders. Once you do this, now you can do this. 7 plus 2 is 9x squared. And then bring down your next numbers. Now in this case, go ahead and bring down both of the numbers. Go ahead and bring down the 12x and then bring down 5. Go, question. And once you've brought everything down, you start the problem over. Now you're going to take 3x and you're going to divide it into 9x squared because now you have a new first term. So you do the same thing again. 9x squared divided by 3x. 9 divided by 3 is 3. And same thing again with this one, it's x to the first power, so you're basically going to knock one of the powers off. So that'll be 3x. And that'll be your next number that goes up here. And then same thing again. Now you're doing distributive property. Now it's 3 times 3 for 9 x squared, 3 times 1 for negative 3. And just like with the other one, you've got to go back and change both of the signs. Now minus 0, that's what we want because we want that gone. 12 plus 3 is 15x. And then the minus 5 is the bring down part that will bring that part down. And then once you're there, one more time, you'll divide the numbers. You're going to take 3x and divide it into 15x. In this case, the x's will cancel out. 15 divided by 3 is 5. And that'll be the last number that we put up top. 5 times 3 for 15. 5 times 1 for 5. And same thing again, go back and change both of the signs. And this one comes out to be 0. So there is your answer. Just kind of pull out 2x squared. 3x and 5. No, not necessarily, because if this had been a negative 9 for this problem, we had taken 3x, you'd taken negative 9x squared and divided it by 3x, this would have been a negative 3. So that would have made that a negative. So it just depends, really it's going to depend on the signs here. That if this sign is positive and this one over here is negative, you're going to do a positive divided by negative so to make it a negative. Okay, now, and on these problems, if remainder is 0, they may ask you to fill in the blank, put the remainder is. The main thing is, if we're filling this out on the test, give me that part. If the remainder is 0, I'm not worried about the remainder. The only time I'm going to ask you to worry about the remainder is if it's something other than 0, then we'll bring it back in. If 0, you don't have to put it. Now, online homework might ask you for it, but if they do, that's fine. Most of the time they'll give you, they should give you a box for that one, or they'll give you an option that there is no remainder. One of the two, they'll give you something to check off on those. Okay, so there's long division. Everything we're going to do from the first, I think there's 1 or 2 problems where you have to do long division. Everything else after that, we're going to do synthetic division. Because it's a whole lot faster, it's a whole lot shorter, and it's once you get the hang of it, it's a whole lot easier than going through and doing long division. There's some long division ones that you can do with synthetic division. Now, and you could do long division with the synthetic division problem and still get the right answer. But once you get the hang of synthetic division, it's one of those where, especially if it's a longer problem, if you have, I don't know that you're getting this long, but if you had 7 terms, if you had like x to the 6th, x to the 5th, synthetic division is 10 times faster when you're doing a problem like that. If it's a short term like this one was, where we'll get a 3-term answer, synthetic's probably still a little bit quicker, but it may not be a whole lot quicker. The more terms you get, the more to your advantages is to do synthetic division. For the most part, yeah. There's some problems if with long division you can do any problem anyway. Synthetic division, first you have to divide it by just x plus a number. So it has to be x plus the number or x minus the number. The problem you had, let's just scroll back up real quick. This problem, because it's 3x minus 1, because of the 3 that's in front of the x on this one, you couldn't do synthetic division with that one. It doesn't work if this number, the coefficient with x, has to be 1. I guess would be the best way of saying that. Okay, so if you want the mathematical term on that one, the coefficient of x, if you're doing synthetic division, has to be 1. If it's not 1, you can't do it. Yeah, that one you'd have to do long division. Now, most of the problems that they do, even with most of the long division problems, there may be 1 or 2 that you have to do long division, but even some of the long division problems, they'll start with x plus or x minus something, so you could go ahead and do synthetic division just to do it a little bit quicker if you wanted to do. Okay, now this one, there's certain steps that you have to do that with long division. Yeah, we still have to do, the terms have to be in order, and if there's any powers of x that are missing, you have to go back and put a 0 in place. Both of those things are still in effect when you're going through synthetic division with those parts. But here, this one has certain steps when you go through this one. Now, and this is one of those things where it's going to take us 5 times as long to write out the steps and actually put them into words. Where when we do it, it's just going to go bang, 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 and it's going to go real fast. But writing down the steps, it just takes a little bit longer, so we just have to kind of, get through this first part, and it'll get better as we go along. Okay, so step 1, and we'll go ahead and rewrite or re-say what we said earlier. Terms must be in descending order. And no powers of x are skipped. So that's the first, and that's the one check you want to do, whether it's long division or synthetic. You always go back and check that if there's any terms at all missing, you go back and put a 0 in place. If the terms are not in descending order, just rearrange them so they are. So that's always the same, no matter if you're doing synthetic division or long division. Okay, step 2. Here's where it starts changing. You're basically going to take your division bar that you have and draw it upside down. And I don't know that that's a step, but I've always written it in this way just to kind of go through this one. So draw your division bar upside down. And we'll say it this way, and bring down or write only the coefficients. That's only inside. Because you got inside the division part that you're doing, you got the part that's on the outside. So for this one, we're taking our division bar that we had before that was like this. Now we're going to flip it upside down and do this. And the only thing we're going to need when we do this is going to be just the coefficients. All the x terms, x squared, x to the third, x to the fourth, all those parts of it, we're not going to need this for this one, and that's what makes it the synthetic part. All right, here's the biggie that you've got to make sure that you do. And a lot of times this is the one thing that'll sneak up on people and they'll forget to do this one. On the outside, comma there maybe? I paused, so I'd put a comma. Don't know if you're supposed to or not. Anyway, on the outside, change the sign, or change the plus or minus sign. And bring down only the constant. So, if it's x plus 1, change it to a minus 1, and on that part, same thing. You're not going to bring down the x, you're only going to bring down the number. But the one thing you have to do is you have to change that plus or minus sign. A lot of times people will go through this one and they'll forget to change the plus or minus sign on the outside. They'll do everything else correct and they'll forget that one little thing and it's going to throw the whole thing off. Okay, oh, we're at the bottom of the page. All right, so this will have to go into the next page. Okay, so we've got a division bar that's upside down. We've got only numbers, inside and outside. All the X terms are gone. Like that. Here's where we get that mathematical term again. We're going to bring down I'm going to say bring it down. We'll say below the division bar. Bring down the first number that's on the inside. And you could call this 4A or 4B. We'll just call it step 5 because it's the next thing you're going to do. Now you're going to multiply. The outside number by the bottom number. Alright, and if you're doing multiplication, the answer to the multiplication problem is product, so forget what the mathematical terms here. We're going to say we're going to put the product inside underneath the next number. And again, since we're starting all the way to the left, it'd have to be the next number to the right. So taking the outside number, multiply it by the bottom number, and that's going to go on the inside of the next number. So we're taking the number here, multiply these two. This answer is going to go on the inside underneath the next number. And here's where you actually get to do the first little bit. Now, we're doing multiplying. Step 6 then is you're just going to add these two numbers in the column, or subtract depending on what the sign is. So either add or subtract the numbers in the column and put that answer below the division bar. Okay, now that you've got the number below the division bar, back to step 5. So then you're going to repeat steps 5 and 6. And basically you just keep doing that until you run out of numbers. Okay, and then the last thing, here's where you've done all the work to it. The last thing is where we'll just go back and put it, because at this point, all you've got is just a bunch of numbers. We don't have any x's in this one. So here's where we're going to put the x's back in. Taking the numbers that's below the bar. So we're going to start with one with. Hang on, try that again. Start with 1 less power of x. So taking the numbers on the bottom, you're going to basically reintroduce, put the x back in, starting with 1 less power on all the numbers below the bar, and then just count it down. So start with 1 less power of x with the first number below the bar, and continue with descending order. Okay, that very last number would be just like we were doing when we were doing long division. The very last number that's in the list is always going to be your remainder. Okay, I didn't put a timer on. I wish I had. Took us 4 minutes, 5 minutes, whatever to write the steps out. This is one of those things when you do the problem, you're done in about 10 seconds, maybe 15. All right, so let's show you a problem. Let's kind of give you an idea of what we're looking at when we're going through this thing. Right, now I'm going to go ahead and put the number off to the side and have it set up. Sometimes I'll have it rewritten different ways, but we'll just go ahead and give it to you so we don't have to rewrite anything. So let's do x minus 1, and let's divide that into 4, x to the third, minus 3x squared, plus 3x minus 1. Okay, so again, take the division bar, just flip it upside down, and now, do your check first. We've got 4x to the third, x to the second, x to the first, and then x to the 0 power, which is basically a constant, so everything's in descending order, all the powers of x are there. Bring down just the numbers, and bring the signs down with it too. So you've got a 4, negative 3, and if it's positive, I'd say go ahead and bring the plus down, just so we don't leave anything out. And on the outside, make sure you change that sign from a minus 1 to a plus 1. And if you want to go ahead and put a plus 1, again, just to make sure that you change the sign of it. With the plus, you don't need it, but just get in the habit of doing it, go ahead and change the sign. Okay, bring down the first number. And then here we go. Now we get to do the actual math here. 1 times 4 is 4. Again, it's positive, so I'd go ahead and put a plus there. And once you multiply these two numbers, add or subtract, whatever it is, it's negative 3 plus 4. If you want to go this way, it's 4 minus 3. So that's a positive 1. And you're going to multiply again. Now it's 1 times 1, which is just 1. And you're going to go ahead and put the plus. So now it's 3 plus 1, which is 4. And then one last time. It's 1 times 4, which is 4. And 4 minus 1 is 3. Okay, and there's all the math done in just a few seconds. Okay, now, again, the answer's got to have, because if you go back to the thing about long division on this one, if we keyed on the first terms, you would have taken 4x to the third and divided it by x. So for that one, we knew that 4 divided by 1 would have been 4. That's where we get the 4 here. X to the third, if you're dividing it by x to the first, you're going to knock it down by a power. So we know the first term would have been 4x squared. So this one, when you put the x's back in, just make sure this one's x squared. The next one will be x to the first. This one's going to be x to the 0 power. And then this is going to be a remainder of 3. So they'll either write it this way, where you put the remainder in, or... Now, again, if you don't want to put the 1x here, you don't have to. Or we're dividing it by x minus 1. So it could look either one of those two ways, and I don't really care. Either way is fine with me when you're writing them out, because it says the same thing. And again, you may want to take those 1's out with the 1x, because sometimes they're okay leaving those in there. Most of the time, they're probably going to tell you to leave that out. Okay, now let's give you one where everything's not perfect, that we got to go back and rearrange and pick some stuff up and put this here and move that there and do a few things with it. Or any questions before we go through the next one? Everybody, someone okay there? Okay, so let's say that's your problem. You've got x plus 2, we're going to divide it into 3x to the 4th, minus 2x squared plus 5 minus 10x. All right, first thing is, it's not in descending order, so the very first thing is go back and rewrite it so it's in descending order. We've got the 2x squared minus 10x and then plus 5. And for that one, it's in descending order, but x to the 3rd power is missing, so you have to go back. If you want to put a plus or, you don't have to put a sign really because 0 doesn't have a sign, but just put a sign there. Let's put a plus 0x to the 3rd. So when they give you this problem, this is actually what you have to do. It's got to be in descending order, and we skipped over x to the 3rd, so you've got to put a 0 in there as a placeholder. Right here, it's missing. And if you don't put that in there when you start doing your division, you'll get an answer, but it's not going to be the correct answer. That you have to have every single power of x, because if you think about, like, if you go back to when we're doing the division back here, it would be like taking 45 and dividing it into 9, and then just skipping a hundreds place. Or let's say the thousands place wasn't there. You have to put a 0 in there, right? Because if you don't, then you're doing 973 and not 9,073. So if they skip a term, they're just kind of saying, well, there is no x to the 3rd term. You just got to know you got to go back and put a 0 in there. I'd put it doesn't really matter because it's 0, but you can put a minus with it because it's not really going to do anything. It just needs to be a placeholder. So, all right. So from there, now we're ready to actually go back and do the synthetic division. And again, key thing is make sure you change that from a plus 2 to a minus 2. So I need 3. Again, 0 doesn't matter if you put a sign. I'll just put a plus just to make sure I've got a sign on it. So we've got 3, 0, negative 2, negative 10, 5. First term is always there just to kick it off, to get it going. Don't do anything with it. And then from here, you're going to multiply. Negative 2 times 3, negative 6. 0 minus 6 doesn't change anything, so this is still just a negative 6. Negative 2 times negative 6 would make that a positive 12. Negative 2 plus 12, or again, you can go reverse order. If you're going to do 12 minus 2, that's fine. That's 10. Negative 2 times 10 is negative 20. So it's going to get negative 30, and negative times negative is a positive 60. Put them together and make it 65. So this one started off with 3x to the 4th because we're dividing it by x. Every time you're going to knock it down 1 power. So instead of starting with x to the 4th, just start with x to the 3rd. And then just count down. This one's x squared. This will be x to the 1st. This would be your constant term. Again, that last number would be your remainder. And for this one, we'll just put remainder 65. Whether it's in fraction form or division with, or just a remainder, either way is fine. What you go there. Okay, so one of those things where it takes 5 minutes to write down the steps, it takes a whole lot less than that to do it by actually doing synthetic division. And again, you could always go back and do long division with any problem and see if you get the same answer. But long division, it's called long division for a reason, because it's going to take a longer time to do it. Synthetic division is going to cut it in half or even sometimes depending on the problem, probably half, because the problems y'all have shouldn't go past x to the fourth. I don't think they'll do x to the fifth, x to the sixth. I think x to the fourth is about as high power as they'll go for these. Okay, once you've done a handful of problems on this one, they do a couple of things. Now, and here's where I'm going to be honest with you. I know there's a homework problem where it says do synthetic division and do the remainder theorem, and I'm going to show you the remainder theorem next. You don't have to do both, because if you do one, the answer should be the same as if you do the other one. So there's no need of doing both of them, because it's going to say do this and tell me what's the indicated value, or tell me what the answer is going to be. It's the same either way. So don't do both of them, just do one, because it's going to be the same answer either way. Here's what the remainder theorem says. The remainder theorem basically, and again, it kind of ignores everything else. It only looks at what the remainder is, and we'll use the problem we had before. But basically it says this. So I think this would be the best way of saying it. The outside number from synthetic division I'll put a comma because we'll kind of make a break here. When evaluated, into the expression on the inside, when evaluated when evaluated into the expression on the inside. Will give you the value of the remainder. Now, and again, this is just a check that you can do, because there's going to be something, and we'll get to this in the next part of it. But sometimes, if you know what the remainder is, that tells you whether or not, that in a minute we're going to, in the next couple of sections coming up, that if the remainder is 0, that's something we want. Because if the remainder is 0, that tells you that the number you're dividing by is a factor or a solution of the expression that you're working on. And if you get a solution, that's a point, that's where you're crossing the x-axis, that's a value that's important to us. So the whole thing on this one kind of keys on this part, that is, it's some of the problems that we're going to do in a little while. The other stuff, yeah, is important, but we're also going to need to know, okay, if this is a 0 remainder, that's a good thing. That's what we want, because we actually get an answer to the problem, and it helps us to get the stuff that we're going to do. So this is something they're saying that you can do this later on if you need to check something to make sure you've got the right answer that you're going for. Okay, so from the previous problem. What was it back up here? We were taking x plus 2 and dividing it into 3x to the fourth. X to the fourth minus 2x. Was the 5 positive? Okay, so it was positive. Okay, so that was the original problem that we had. And again, we were taking negative 2 and dividing it into this thing. But here's the key thing that we need from this one, is that we use negative 2, right? So what it says is that if we take this negative 2 and we're going to plug it back into each one of these x's and work it out, then if we do this correctly, the answer we get when we do this and plug it back in should be the answer to this remainder of 65. Okay, so let's see what we get there. So we'll take out, let's take out the x's here. So we're going to have 3 times -2 to the 4th minus 2. Now somebody may be asking, do we have to go back and use the part we had in synthetic division? No, because all we did was just rearrange it and put a 0 in there. And because you're going to multiply by 0, you don't have to use the 0 term, because if you multiply anything by 0, it's still just going to be 0. So for this one, you can just plug it back into the original problem that we've got. Squared plus 5 minus 10 times -2. Now, here's where it's all calculated. If you take the numbers and plug it back in, if you've got any scientific calculator, just punch it back in. Plug it back in, work it out, and see what you get. We'll kind of go through it by hand here just because we've got it set everything up. If you do -2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 3 times 16 minus 2, 2 squared is 4, plus 5, and then -10 times -2 would be a plus 20. 3 times 16 is 48. 2 times 4 is 8. Plus, go ahead and do 5 and 25, make that 25. 48 minus 8 is 40. Plus is 65. There you go. So it checked. So if we were doing a problem and you wanted to, say you got an answer that you got then, you were like, 65 seems like a big number to get for remainder. If you want to go back and check it, that's how you would check it. You would plug it back in, and this number should be the remainder. And somebody says, what if it's not? Well, either you did your synthetic division wrong, or you did this part of it wrong. And the bad thing is you don't know which one you did. That was incorrect. So, and that's why I say don't do both, because it should be the same answer. They tell you to do synthetic division and do the remainder theorem. Don't do both of them, because there's no need of doing it. Unless you just want extra practice, then knock yourself out and go with it from there. Now, one thing that they will do differently here on some examples is they may tell you to, when you're working through this one, they may give you a function and we're not going to actually go through and do the whole thing here, but let's say this. Sometimes they'll give you a function like this, and then they'll say f of -4. And they may tell you to use the remainder theorem. If they give you a problem like this where they tell you to use the remainder theorem, they give you a function, they give you this number, you don't have to change the sign for this one, because by it being this number that's here, they're already telling you, okay, they've already said, we want you to plug in x for -4 because they've already got it written this way. You just take the -4 as it is, and then go back and plug it back in, and then work it out from there. Now, we're not going to do that because it's just evaluating the problem, but if they actually give you a number like this, where they tell you it's f of this number, the sign's already changed for you, just plug it in. That's all you have to do. There is some in the homework like that where they give you the function like that and it says use remainder theorem. So when you see that one, don't change the sign, just take that number as it is and go with it there. The only time you have to change the sign, stop there, is if instead of giving you this, they had given you x plus 4. Okay, then you got to change it to the -4, but in this case, it'll show up here. They did it for you, so then we're good to go. Okay, so that's the only thing that's different here. Last thing, and this was really kind of, they're kind of previewing what's coming up in section 5 and 6 with these, is because they're going to give you, here's what the last thing they ask you to do. And it's another one of those problems where they don't tell you exactly what to do, but I'm going to tell you what to do because they don't. Okay, so they'll tell you, here's an equation, or sometimes they'll tell you, here's a function. And they want you to solve it given that 2 is a 0. Alright, so here's basically what they want you to do for something like that. When they give you a problem like this, when they tell you that 2 is a 0 or 2 is a solution, or how they word it, that means you have to do synthetic division. With that number. And that's really what they're saying. And it's going back to the whole thing of that this thing is a 0, which basically means it gives you a 0 remainder, which means it's an answer, it's a solution. But the key thing is that for this problem, the way it's set up is they're telling you, all right, this is a factor, which means we needed to do division with it. So we're going to take this problem we've got here and do synthetic division with this number. Now, they've already changed the sign for you, so they're saying, all right, this one's a solution, do synthetic division with this number, that it's pretty much the same as this problem back here. If they don't put x plus or x minus with the number, don't change the sign, because in this one they gave you 2 is the number you want, do synthetic division with the 2. That unless they do x plus or x minus a number, if they give you a number, that's the number you've got, and then just go with it. Okay, so we need a 2 minus 5. That would be a plus 1, and then a plus 2. Okay, key thing is first number always comes down, so we'll bring down the 2. And then we've got 2 times 2, which is 4. Now, the good thing on this one was they told us that it was a 0, which means at the end, we already know the remainder has to be 0. If it's not, you did something wrong. You got to go back and check your synthetic division. So 2 times 2 is 4, negative 4 plus 5, or negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. Makes a negative 1. 2 times negative 1 is negative 2. Put those two together, we've got the 0 remainder. Okay, now you may go, okay, we already knew that. They told us that was the solution coming in. What does that do for us from here? Here's what you have to do for the rest of it. This was x to the third, so this answer would mean this is going to be 2x squared minus 1x minus 1. Because the remainder was 0, it already gave us that. Here's the whole thing you're doing after you get the synthetic division. Whatever you got left over, when they're telling you to find the other solutions, what they want you to do then is they want you to factor and solve whatever you've got left over from your synthetic division. So we're basically going to do this. Now, and again, they should not ask you to do quadratic formulas. These every answer you get on this one, when you get to here, when you got whatever left over underneath the division bar, that part should be factorable. Don't do quite. Some people ask for it. What if it doesn't factor? Well, then it does, because we're not expected to do the quadratic formula on this one. Those answers should factor. If not, you got to find the factors. It's there. You just got to go through and find it. For this problem, it's set up pretty well because there's only one way you can factor 2x squared. It's got to be 2 times 1. So we'll have a 2x here, you'll have a 1x here. There's only one way to factor negative 1, it's positive 1 times negative 1. You just have to figure out which one's positive and which one's negative. To get the answer to be a negative 1, let's see, this is 1, that's 2. We're going to need the negative here, and then the positive is going to go there. And then once we've got it factored, set each parentheses equal to 0, which should be really quick and easy to get the answer. This one you'll subtract 1, and then divide by the 2. This one you'll add 1 to both sides, so then you get x equals 1. The one answer that most people will forget when they say find all the solutions, they gave you x equals 2, don't forget to write that in it, because they gave it to you. That's a freebie. You had to find the other ones to kind of go from there. Okay, so, and that's usually the one that most people miss, and it's after you do the problem, you go, oh, well, duh, they gave it to you. You just got to know to go back and bring that in, because they told you, here's the answer, so that should be the first answer, you just got to find the other ones that go with it there. Okay, so that's the last thing they do, and then all those are just variations of doing synthetic division. So when you get a problem, you're doing synthetic division on all these, unless it says do remainder theorem. But you just got to kind of know how to read through it to know exactly what they're asking.